Build Show. Steve Baczek, architect for the Build Show. Yeah, we are down here in coastal Massachusetts, Forever Home. And yeah, very exciting times. Hopefully you watch the videos on the foundation, the demo, and the insulation on the outside, because we're about to head up to the job site and talk about floor framing, which is always one of my favorite pieces. Like, you actually see the beginnings of that house getting built. But before we head up there, I wanted to give you a little postcard of what it means to live in New England. We got boats in the water, we got docks, we have a beautiful osprey nest right there with mom guarding it. Anyways, let's head on up the road and we'll catch you up there at the Forever Home and we'll talk about floor framing.
Forever Home, a Build Original series, is brought to you by Builders First Source, Baczek Exteriors, Huber Engineered Woods, and Rockwool. Forever Home, a Build Original series.
Floor framing. Guys are putting it down over there. We're going to dive into it, but I always think it's important for some of our viewers, and I know we have everything from the new do-it-yourselfers to young builders, young architects, to seasoned professionals, and the seasoned professionals are probably like, Steve, you were going to bore me, but I am. I'm going to walk through the numbers because I think it's always important about the decisions that we make on projects. Why did we make those decisions? And what are the products that we in fact are using? First thing, of course, is the floor joist. And these are floor joists that come out of Canada, and they are a trimmable floor joist. You can see there. And I have all these materials over there. We're going to talk about them in depth, but we have a trimmable floor joist. We have our band joist over there, which is what goes around the outer edge. And then of course we have our floor sheathing, which is made by Huber Engineered Woods. It's Advantech by name, and it's a 3/4 inch floor sheathing. And we have all those samples. So I'm gonna take a quick walk over to the sawhorses, catch up with you there, and we'll go break down every piece of this floor frame. All right, so I got a bunch of the pieces that we're actually using as part of the floor framing package here. There's basically, like I said earlier, 3 major components: the floor joist, the floor sheathing, and then the band joist. So let's first talk about what goes on top. It's probably the last thing of the floor frame. We'll work in reverse. We have Advantech here. Advantech is made by a company, Huber Engineered Woods. It's a 3/4 inch OSB. OSB stands for Oriented Strand Board. You might know some of their products as Zip, which is OSB for the wall with an integrated weather-resistant barrier, but this is actually their floor sheathing. And the thing to make note of is, because this is OSB, and you can see I grabbed the little piece here, it's basically just a bunch of strands. They are actually placed on the platform in a very specific, logical, engineered pattern, because that develops a certain level of strength, right? These in fact are a beam. When you go in between the floor joists, this is acting like a beam. You don't want to have it deflect in between those floor joists. So it needs to be strong enough to carry that. Getting back to my other point there is, because it's OSB and the zip on the wall is OSB, don't mistake them for being the same thing. I know a lot of people, whenever I post something about OSB, they lump it into this one category of OSB. There's tons of different OSBs being made out there. There's commodity OSB that's really cheap. It's made for the agricultural industry. It's made to get beat up, thrown away, be temporary. And then you have the better quality, or the highest of quality, of OSB, which is the Advantech. And the reason for that is understand, this is getting installed on the flat. Now, yes, hot day here, middle of August, I'm sweating. There's probably no challenges here. But you've seen some of my videos where we might have a pool of water after a rainstorm. We might have 6 inches of snow and ice sitting on this in February as we're framing a house. So the Advantech really has to be built and developed for the worst case scenario, not a hot sunny day like today. And in fact, that's what it is. The minute I put it vertically and call it a wall panel, it's going to shed that water. So those challenges of being compromised by something perpendicular to the surface really don't exist on the wall panel. So they can take out some of the glue, they can change the composition, the size of the strands. There's a whole bunch of things that change it to make one Advantech and one zip. Here's a full sheet, and this has two ends, or let's say three ends. It has the butt ends, which are the short side. There's no profile there. This leading edge here, this is the male end. There's a little tongue that sticks out. And then on this side here, we have the female end, which actually has the groove. Now, one thing to understand is that the groove restricts the placement of this before it hits the end of the tongue. And the reason for that is it gives that panel a little bit of movement in there. So if it gets wet or definitely out in the sun and expands a little, then it has that ability to creep laterally. And we're not talking this stuff's moving an eighth of an inch. It's probably moving a 64th of an inch, but it doesn't develop that buckle. And that's what we're trying to avoid in doing that. Plus, the tongue and groove interlocks each panel so that the diaphragm, which is basically the floor sheathing as a whole, is a structural diaphragm that can now work in unison to provide some level of shear to the building because all of those panels are interlocked. And of course, all of the panel joints are staggered. You just don't put 4x8 sheets down and then you put 4x8 sheets next to it. It's you start out with a 2 foot by 4 foot and then a 4x8 and then the next one's a 4x8. So all of the joints are then staggered so we don't again get that one continuous line across the building. We want that diaphragm to work in unison, but we don't want any weak points where things are perfectly aligned. We're using the 3/4 inch here, as I mentioned, but understand they do have 7/8 an inch and an inch and an eighth, depending on what type of subfloor you want to put in. If you go to a 24 inch on center, you might consider moving up to their inch or inch and an eighth product. But remember, each one of those floor sheathing, it's working like a beam. So obviously the inch and an eighth is going to have a different deflection rating, bending rating than say the 3/4 is. And it's going to be a lot stronger, right? So let's move on. Around the perimeter of the floor frame, we need to close off the floor frame. So I typically call it a band joist, which is this material right here. It might look very similar to the Advantech, but like I said earlier in the comparison between Advantech and Zip, the band joists here, and these are made by, I think it's Tolco, and you know, these strands, you can see they're much larger, but it's almost like a PSL, parallel strand lumber. But in fact, it's looks pretty darn close to a cross section of the Advantech there. But the band joist job is to literally run around, and it's kind of the belt to the floor frame, right? It closes everything off and it allows us to bring roof sheathing or wall sheathing down, attach to it all of our cladding, and make that connection down to the foundation wall there. So lastly, the floor joist itself. So grab this one and slide it down here. First of all, open web truss that has a trimmable end, and it's pretty darn light. These are made by a company called Triforce, and it is a web truss. Now, one of the things that I really like about this is, notice in their trusses, there's no connector plates. Everything is grooved and inserted in those grooves and glued. And the beauty of that is you can put an electrical wire here, pull it across the basement, and you don't have to worry about shearing off the cover to the electrical wire because there's a metal plate here. And those metal plates, you know, even though it comes up a little, it's still going to diminish this opening by maybe an inch or so. So not having those and having this nice and clean all wood connection, I think there is certainly a benefit to. In most materials, you'll understand that you can see here, this is the model or series number, OJ314. They've even labeled, this is the bottom. So as an engineer or an architect or lead framer, general contractor, if you show up at the job site and you see this installed this way and you look down and see the word bottom, then obviously it's been installed wrong, because I shouldn't see that unless I'm walking around in the basement. The other thing on here is there are stamps, right? Made in Canada. These are made up in Quebec. A bunch of ESR numbers, which is how these things get tested, and then the lot number, timestamp, and everything, so that if there was a failure somewhere and the company said, okay, well, let's go look at that lot number and see if there was something wrong in our factory, they can take this joist and pinpoint the date and time that it was made in the factory, so that they can go back and understand, hey, did we have a problem in the factory? Was it just with one truss? What's going on there? It allows them to have that opportunity to do that. Rolling this over and putting the bottom on the bottom, sliding this down, you'll notice the end of it, the truss stops, terminates with a vertical member, and then we have a web. So this web goes from open web truss to basically what we would term an engineered floor joist. And I'll spin this around so you can see it in the camera, but it is a bottom chord, a top chord, and then the web member, right? If you notice, it directly reflects the same shape as a typical steel beam. And that's because in all beams, the governing factors in a beam are the depth. And I'm saying governing factors in terms of strength. They relate to the depth, they relate to the width of the chord and the depth of the chord and the size of the web member. Now these here, we have two on this job. For the heavier loads, which you see that are going up behind me here, those are 22-foot spans. Those actually have a 3.5-inch web, because we get more strength by displacing those webs and having a larger web there. In the places where we have shorter spans, we can downsize these to the 2.5-inch web. They all carry the same 3/8-inch webbing inside, and they come in 2-foot increments. And you're allowed to take those 2-foot increments and cut up to a foot of it off and use it and still be respectful of all of the loads that are carried. You don't want to cut less than that foot, but you can cut up to a foot off, which then puts you into the realm of either a size 2 foot shorter or 2 foot longer, depending on what it is that you need. I've used these on a lot of projects, Triforce. Framers really like them, easy to handle. Mechanical guys, plumbers, everybody likes them. General contractors like them, and eventually homeowners like them, because now I'm not cutting holes in here to run a toilet drain or something from one bay to the next bay. I have this nice space here that we can do that in. So those are the three major components of the floor frame. There is a fourth, the LVL. Why don't we'll jump down in the hole and we'll go and look at some of the stuff that gets done before the joists get in place. So I'll see you down in the hole. All right, so we made it down into the hole or basement, and you can see that we have some floor joists in, but notice we have some solid, what you might consider floor joists, but those are actually beams, and their correct terminology is LVL, which stands for laminated veneer lumber. It is in fact a beam, but so isn't a floor joist, and we'll talk about that a little later. But the LVLs are a lot stronger because they get their strength from the lamination. So you can see here, I mean, these are 1 3/4, which means that they're probably over a dozen laminations, but you can see it is made no differently than plywood. It's just made in an 1 3/4 format. You can also get them in 1.5 inches. The standard on most of our projects are 1 3/4. They come in 7 1/4, 9.5, 11 7/8, and then 14, 16, 18, 22, 20, 22, and 24s. I've actually been to the factory, and when they make these, they make them in anywhere from around 58 to 60 foot lengths, 54 inches wide, and then they cut them. and then they treat the edges. But you can see, you know, this is one that's cut on the site, this is cut at the factory, and then they treat it with kind of a waxy finish so that moisture doesn't get in there and ruin it. It's the multiple laminations and the depth that give the LVL its strength. So whenever we have to go to a beam like that one is actually going to be carrying a wall above it, and then the wall above it is going to be carrying a shed roof into it. So half of that roof load is coming into it. So we had to move to a beam there, and that's why you're not seeing it as floor joists there. One last thing, I want to just take a quick walk over here. You can see we have all of our footings. We talked about those in the concrete episode, and you can see the guys, you know, framers, they just put up temporary posts here. Notice it's not in the center, and that's for good reason, because we're going to put the actual column that's going to live there. But these are temporarily setting up those beams, and if you look beyond, you can see that beam sits in a beam pocket, so that this is a beam that I would call a dropped beam, instead of a flush condition where the top of the beam is flush with the top of the floor joist. In this condition here, you can see all of the floor joists are going to sit on top of it. So that's why I call it dropped. It's dropped down into the basement. The drop beam necessitates the need for a beam pocket, which is coordinated with the concrete guy to develop the hole, basically, or shelf, to place those beams on. The intermediate supports, they're all laid out in the floor plan, and I'm not going to lift them, but these are called lolly columns, and it's L-A-L-L-Y. You can go on there. There are rated 3.5 inch and 4 inch. I think a 4 inch by like 9 foot. It could carry up to something like 18 kips, kip being 1,000 pounds in structural terms. But they are basically a thin-walled steel pipe that is then filled with concrete. Now, in structural terms, the reason for the two materials in a lolly column, one, it's got a steel outside, because there's this value called K when structural engineers are designing them. And what the K value is the ability for the column to bend under load. Think of me as a column. I could probably hold 100 pounds over my head pretty easy. If you put 500 pounds over my head, I'm gonna buckle, right? And my back will probably give out and I'll buckle sideways. Well, the same thing for a column. That K value establishes kind of the buckling potential, if you will, or the buckling strength. Columns can certainly fail vertically and just crush, but that's why they're concrete filled, so that's not going to happen. And the steel helps contain that concrete. But the steel is good in tension, so as that load transpires down vertically through the column, any reason to kick out and bow, the steel battling the tension helps keep that column vertically straight. So lolly columns, concrete filled, steel tubes. They're going to have bases. They have pieces that connect up to the LVL to keep them from sliding in and out in case somebody comes down here and hits them with something. They don't just fall over. Time to jump up topside. We'll catch up and we'll see what the framers are doing, and we'll go right from the mud sill right through some floor joist placement, and then that'll be it for floor framing. When we head back up the ladder, and I'll see you up on top. All right, so we made it up. You can see framers are well underway in starting here. We got a bunch of floor joists up. We have some LVL beams, but we have a section here that they intentionally left off. You know, one of the things about these videos that I gotta give a shout out to Shoreline Builders, the framer. You know, these guys are really good about saying, okay, we'll leave a corner of it open so that you can do, you know, a little educational video here instead of closing this all off. So understand, for your benefit, these guys are kind of stopping work, going to do something else instead of closing off this work, so we can have this conversation. So big shout out to Shoreline and their subs for doing that for us. But anyways, so we're looking at basically a cross section. We have the foundation underneath here, right? Concrete. Then we have a 2x8 treated mud sill. Because it's in contact with the concrete, which can wick water and move water through capillary action, right? Wood can too, but any wood via the code that's in contact with concrete has to be a treated or non, rot resistant or non-rotting, rot resistant type wood there. So we use a treated southern yellow pine. And in this case here, it's a 2x8. And I call that the mud sill because that's basically what sits down on top of the foundation. And then on top of it, we have a 2x6. So we basically have two sills. And the reason for the two is we're gonna have a zip R6 sheathing, 1 7/16 that's gonna come down. That sheathing's gonna come down and sit on top of here. That's gonna keep critters from having access to the underside of that foam and give us a nice clean edge. And you can see that turns the corner. In fact, it goes around the perimeter of the full foundation. So those sills get set. They get set. You saw the anchor bolts going in, and you can see them here every 4 foot on center within 12 inches of the corner. Now, in the introductory video you saw, we are probably 1/8 of a mile from the water. That puts us in a high wind zone. So some things we have to do here, we have to upgrade. One of the upgrades is we move to a 3-inch square washer here because it's harder to tear that plate off now with that larger washer basically holding it down. But before the mud sill and the top sill get put down, we have that concrete surface, and the concrete surface is somewhat of an irregular surface. The wood surface is maybe microscopically irregular, but it's a little better than the concrete. But when those two join, there is probably some spaces in between that. So we need something that picks that up. So typically we use what's termed a sill sealer, and this is just a closed cell. It's a foam, 5.5 inches wide. It would typically just get laid down underneath, but in our standard in the office, we like to take this and make it just a little bit better. So when we set it down and the concrete foundation wall is here and the mud sill sitting on top, we like to put a bead of sealant under it and a bead of sealant over it. And then that puts this into this kind of Z, right? And that Z, when it gets squished down, that really ensures that we get a really good seal across there. Now, some builders sit there and say, Steve, that takes us forever to do. We just like to tape the sheathing to the foundation, and that's fine. They make some tapes there that are vapor permeable. I personally like having the bottom or having that sheathing somewhat open and have that wood open, that treated wood open to the bottom so that it can dry out. You guys know I'm a big proponent of not sealing things up, but protecting them, but always providing a path for water to go and the ability to dry. I like this detail because it buries it in there. It is a little bit more work, but what are we talking? A couple hours more on the foundation here, and this is a detail that's going to last the lifetime of the house. Now, as far as the sealant that we use there, typically our go-to is Lexel. This is a Sashco. Basically, it sticks to everything. It's a waterproof. It's actually paintable too. We use that as our bead of sealants. The band joist, you heard me talk about it at the horses. You can see it in place here. The band joist lines up flush with the outside of that top sill. Our sheathing is going to come down and get seated on that mud sill there, but notice the band joist traces around the building here. But one of the things I wanted to call your attention to, and this comes from our structural engineer, and because of it, it's in every set of drawings that we send out as a floor frame. Notice one band joist, two band joists, and if you know the reference, it's the count on Sesame Street. One band joist, right? 1, 2, 1. Why is there two here and why is there only one here? Well, when we go to frame the walls up here, every fourth one's going to align. So as they align, that plate that goes across here is catching the end of the joist. So the joist itself is supporting that. In conditions where the band joist is parallel to the floor truss, like here, we double that up. So I increase the bearing capacity. Now, this is likely a gable end on most houses, and it is in fact a gable end here, but doubling it up just gives us a little added strength when we're parallel to the floor trusses there. You can see here we have our trimmable floor trusses are in. Notice all the trimmable ends are on one side. All of the cuts are made either on that side or this side, whatever the case is. But the idea is you want these trimmable ends to basically line up. The reason for that is when the plumber comes in and he wants to slide a pipe in, all of the web members will then line up because all of these joists are made to be identical. So if they're cut identical, it means that all of those triangular openings are identical. As a side note, anybody understand why trusses are triangular? So the bottom chord of any beam, its intention, as I apply weight, it wants to stretch and bend. The top chord is in compression, right? The web members bounce the forces between the top chord and the bottom chord. If you took a standard 2x12 solid sawn and you graphically showed how the forces move through it, they basically ping pong between the top and the bottom of the beam in a truss format. So the truss, in essence, is nothing more than a 2x12 with the pieces of wood that don't do any work cut out. So they are a graphic representation, literally, of what the structural forces are doing inside that floor joist. And so you can see these go in, these are in 16 inches on center. These, when I say on center, meaning on center from here to the center of that floor joist. The very first one, if you're a do-it-yourselfer, you don't pull from the center, you pull from the end. So the end to the center is 24 inches, and then, or 16 inches, and then it's 16, 16, and we'll march all the way down. So we do have a couple of other things that are happening here. You noticed when I was down in the basement, we talked a little bit about LVL. We have a pair of those LVLs here. You can see solid beam because we have a condition up above that's carrying a gabled wall. There's a little build out for a cantilevered little bay window area here, window seat kind of thing happening inside the house that you'll see later. So we needed a beam to come back. That load and those joists will go back to the beam will take it over, put it in the foundation takes it to the ground. Building stands up. That's why we're successful. As far as fastening this stuff, so the framing members, those are a 3 1/4 inch nail. They come in sticks. Here, they slide down into the framing nailer. But one of the things about these, like I said, 3 1/4, and it's 0.310 or some 0.31, something like that is the diameter. But notice it has a little coating down there. Now, I'm gonna go out on a limb here because I was taught that that coating, when the nail gets driven in, that coating activates. And what it does is it increases the friction between the nail and the piece of wood that it's being driven into. So it's not quite an adhesive, but let's just call it a friction accelerator or additive, friction additive. But what it does is it makes it harder for the nail to pull out. So those are used for any attachment of the floor joists to the top sill, etc. And then when we put our floor sheathing on top, we're going to switch to a smaller nail, and these are 2 3/8. So these are 2 3/8, so much smaller diameter, but notice there's a whole bunch of rings. You can hear my fingernail scratch across it. Now, the rings are kind of doing, you know, what that coating was doing, but it's doing it even more in that when you nail these on, not only do you get that friction with that coating, but those ring shanks really give it a larger bite in there because you're increasing the surface area. So when I go to pull it out, there's a lot more friction being developed between the nail and the wood fibers to pull that out. So that's why hopefully our floors don't squeak because we use those. Lastly, if we come around the corner here, I'll just show you a quick detail that we use. Notice on the band joist here, inside we have an LVL. Now, they don't have the floor joist hanger, there's going to be one, they'll slide it in, they'll nail it off, and there's going to be a couple more. I can see they have the marks for it. And basically what we're doing here is we have a window opening to the basement there. Window openings need a header. So I could either push that window opening deeper into the ground, or I could pull that window up to the bottom of our mud sill and then put the header inside in a flush condition on a floor frame. And that's what we choose to do. This is a pretty typical detail for us. In this case here, this is only a 3-foot window, so we run one 14-inch LVL. We run it 6 inches long on each side of the opening, and that becomes the header. Our floor joist here, given that it's a flush condition, those will get hung by these, and then you can see after that we'll get back to our standard floor joists here, and these will be a gravity load again, where the joists are basically sitting on top of that top sill, sits on top of the mud sill, sits on the foundation. So each floor joist in effect is its own beam. Yeah, so about to pack it up. Floor framing, done. What do you say we head out, we return at a later date. We'll give the framers a few days to get ahead of us, and then until next time, yeah, I'm Steve Baczek, architect.